Hello, good morning friends. Welcome back to your favorite channel of Code One Digest. Today in this video we will learn about a Spring Boot Microservice application running with a Postgres database, and database is running in a Docker container. Yes friend, we will run our database into a Docker container and then we'll be connecting our microservices that is running in our host machine to connect to this database which is running in Docker container. Yet this video is going to be very exciting. There are a lot to learn in this video, right? So we will see all of that in this video. So stay tuned and do watch this video till end. Okay friends. So now there are certain tools that we are going to use in this video, like Docker. We are going to use Docker runtime environment to run that Postgres image into a Docker container. Then we'll be using Dbeaver database tool or pgadmin tool to connect to the database to perform certain operation on database. I'm using Dbeaver. If you want, you can use pgadmin that comes with Postgres. Then I'll be using Intellij IDE for my development of microservices. I'm comfortable with it, but you can use Eclipse if you are comfortable with Eclipse. And later I'll be using Postman API testing tool to test my get and post contracts.
Friends, before we proceed in this video, I want you to subscribe my channel to grow Code One Digest family. Friends, I'm creating a lot of quality contents for you, but I'm not getting subscribers. I want you to like, share and subscribe my channel so that I can grow Code One Digest family. Thank you.
All right, let's get started.
Okay friends, now let's see what we are trying to achieve in this video. I'll show you what we are trying to achieve in this video through this architecture diagram. If you see the green area is my host machine where I'm running this demo. On this host machine, I'll be running my application, that is my microservice application or my database access tool, that is my Dbeaver or pgadmin, right? And the blue box that you see here is my Docker container, which is running on my host machine. Now inside this Docker container, I'll be running that Postgres database image that I'm downloading it from DockerHub repository, right? So that image is coming from DockerHub repository and then I'm deploying and running it in the blue Docker container. Now things to remember and things to notice here is the port mapping. It is very important. Whenever we want to access the application which is running on certain port inside a container, so we have to do a port mapping. We always have to do a port mapping. So port mapping is required to map a container port to a host port so that that application running in a container is accessible outside the container in a host machine. So from host machine, we want to access the database in our application as well as in our database tool. So we have to do this port mapping. So we'll be doing a port mapping. We'll be mapping our container port 5432 to 5435, right? You can select any port for your mapping. Even you can do 5432 to 5432 mapping, that is 5432 port of container to 5432 port of host machine. But in this demo, we are mapping it to 5435 in host machine. Okay friends, so now let's start with Postgres database installation setup in Docker container. Let me quickly show you what is DockerHub and how can you download image from there. So this is the URL of DockerHub, hub.docker.com. I'll share that in my video in the description section. You can access that, or you can search DockerHub in a Google and it will take you here. Then you have to log in. I have logged in with my credential. You can create a new account and then start using it. This is my repository. This is my images, but what we want here is the Postgres database. So what you have to do is we have to search Postgres here. You can see the Postgres is available and there are multiple tags available here. We will be downloading Postgres using tag. We can go to tags and see. I'll take this 12 image, I'll copy this and then we'll download this image into our image repository. So let me clear these Docker PS. So I'm not running any container as of now, and Docker images. So these are some images available. If you see, one Postgres image is also available, that but will not use. This is the latest one, but will not use this Postgres. Whatever I am downloading, that I'll use in this demo. And yeah, so now what we are doing it, we are downloading this Postgres 12 Alpine to our local image repository. Yes, so it started downloading. It will take few seconds to download. Yes, so it says download complete. Yeah, so it says it's now completed. Now let's see Docker images. Yes, so you see this Postgres tag 12 alpine is the image that we have downloaded just now, and we will use this image to start our Postgres database in a Docker container. Okay friends, so now we are ready to run our Postgres image into a Docker container. But before that, we'll prepare a command because we have to expose ports and so on. Let me show you where you get the basic command first. So you go back to your DockerHub repository, and then on this image overview, come down, they will give you a reference command. To start Postgres instance, they have given docker run minus name, some name of your container, and then minus e option you have to give. They are saying that you have to pass the password of your choice while starting this image. So we can give a password of our choice here, and then minus d the image name. Copy this command and then we can customize it for our requirement. Let me show you that. Yeah, so if you see, the syntax of docker run command is docker run minus p. P will use for port mapping, and minus p option with host port colon container port. Host port is a port where we'll use in our application and our database tool to access Postgres database, and container port is the port where exactly our Postgres database is running, and then image ID. A final command, if you see at the bottom, docker run minus name, and I'm giving the name of my container is Postgres 12 because I have downloaded Postgres 12. Then minus e option, I'm giving a password Postgres, and then I'm using minus p option to create that port mapping from container port to host port. Then minus d, this is the image ID. So I have prepared this. Let me go back to the terminal and see. Let me clear this. Docker images. Now we'll copy that command and we'll run it. Let me copy that command. So I have that in my text pad. I've copied it, and let me paste it here. And this is my image ID. If you see, this is the same image ID in the image list. Now let me start this. Yeah, so it says started. Let us see if it is running. Now what we'll do is we'll try to connect from our Dbeaver database tool and see if we are able to connect, and then we'll perform certain database operation like create schema, create table, insert data, and so on. We'll do that now. I'm using this database tool. So very first thing that we have to do here is we have to go into database and then create a driver manager. Okay, let us create a new driver for Postgres 12 running in a container. So if you see here, this is the configuration. This is the name of driver I have given, Postgres 12 container. Selected, it's a Postgres type. This is my driver class. This is the URL of my database. 5435 is the host port that is mapped to 5432 inside a container. So this port you must remember in the URL you have to give. Then default port 5435. This is a database name Postgres, and this is a database name Postgres, and this is my default user. So I have to give all of this. In library you have to give a jar file of your Postgres driver jar file. So you can download this driver jar from Postgres website. You can search in Google and download this jar. I will provide a link for this jar also, and then add that here. If you're using pgadmin, so you don't have to download, it will be part of your pgadmin setup. Once this is done, once this driver is ready, say okay, and then we'll create a connection now. So come to a database navigator, say right click and create new connection. So in this new connection, now search for our driver Postgres. So this is our driver Postgres 12 container. Say next. So you can see here it is pointing to localhost and database name is Postgres. Port by default selected 5435, and here it is asking for username and password. If you remember, while running our database we have given a password Postgres. So I have given this password here. Now rest of the thing is coming by default from a driver jar. You will leave it. You first test the connection, it is able to connect or not. Yeah, so test connection says it is able to connect to that database running in a container. right? So say OK and let's connect that. Say finish. It has created a new connection here on your database navigator. Just open that. Open database. You can see this Postgres database is visible here. Now open schema. So it has one public schema available here. Now what we'll do is we'll create our custom schema and some of the table and see if we are able to play with some data or not. Okay friends, so now we are ready to play with our database. We'll create schema and we'll create table and then we'll insert data into a table and then we'll see. So before that, we'll make sure that we have connected to the right database. You can fire this command, select version to know which version you're connecting to. So you're right. It is saying Postgres 12.12, right? So if you remember, we have downloaded this 12.12 from our DockerHub. So it is connecting and printing that version. Now this is a command which will create a custom schema for us. Let me select this and then, yeah, so it says that a schema is created. Let's refresh here the schema list and see if it is visible. Yes, so it is visible. Now if we open this schema, there is no table available inside this schema, right? So now what we do is we'll create one customer table inside that schema using this command. In customer table, I'm having 4 attributes. One is ID, that is a primary key, and then name, it's a character, then age, integer, and role, again character. So we'll create this table. Let me run this. Yes, so table is created. Let's refresh this table and see if the table is created. Yes, so table is created and it is having those 4 columns. We can see those 4 columns. Now what we'll do is, let me insert some of the data into this table and see. I have prepared the insert statement. Yeah, so insert into schema name dot table name, and attributes are, column names are ID, name, age, and role, and then I'm inserting this user Pawan. Okay, let me give ID 2001 Pawan with 32 and then this value, and let's fire this first to see if do we have any record already. So we don't have, it's an empty table as of now. Let me insert this record. Yes, so it says inserted. Let's fire the select query and see if the records are showing up. Yes, so it's showing up. I can see that user is inserted. Okay friends, now we'll see how to do a Spring Boot microservice project setup. So I'll show you how can you do that, and I have already created a project for you. So if you want to learn how can you create a Spring Boot project from scratch, so for that I have already created a video in past. You see this first video, a Spring Boot project setup step-by-step tutorial in Intellij for beginners. So this video you can follow from my playlist, and that will guide you how can you create a project from scratch. In this video I'll directly jump to a project and I'll show you what code I have written for the microservices. I'm not going to cover the project setup, Intellij configuration in this video. Okay friends, now let us start with the Spring Boot microservice project. So this is a project that I have created. So this is a very basic project. In the pom.xml, I have added certain dependencies because we are working with the Postgres. So you have to define a Postgres dependency here. So this is a Postgres dependency that you have to define here. I have shared this project in my GitHub repository, so you can download that project and play with it. Just follow me in this video and then you can download the project and start working. I'll be sharing all the commands, all the database queries, everything in as a part of that project, so it will be there for you. Let me quickly show you my project, GitHub project. Yeah, so this is my GitHub project. Let me show you the code. So let me go to the source folder. In the main folder, then in Java folder, I have this main class. This is our main Java class of our Spring Boot application, having a Spring Boot application annotations here. Then I have a controller layer, then I have a business layer, and then I have a repository layer as I shown you in the architecture diagram, right? So these are the 3 layers that I have. I have written one controller class that is customer controller having two endpoints here. Get customer to get customer information and post customer to insert customer information. Right, so here in this get customer I'm using a path variable. So it is a path variable, so I have selected path variable here and name, and then I'm calling a business layer class that is customer service class here. There is a method in business layer class that is get customer by name. We'll see that what is happening there. We'll go to that customer layer class. So this is my customer service, this is my business layer class. In this get customer by name, it is referring to my repository interface. So I have written this interface and extending this CRUD repository. So this CRUD repository is part of our JPA libraries, JPA dependencies. So here we have to provide a domain object, our entity object. So we are working on a customer table. We have also defined this domain object, and the reference of the domain object will give here in this repository. What we are telling this repository is all our operation in this repository is going to be on this entity object. So I am going to fire all my queries onto this entity on this table. So I'll show you that entity class as well. So what operation we have defined in this interface here? Find by name. Okay, this is standard naming of a method, okay, in JPA, that find in camel case form, find by name, where you will pass a name and then it will give you a list of customers. Okay, I am taking list because we can have a customer with the same name, so it will give you a list of customer object. Then find by role also have defined, but in this demo I'll be using find by name. Other method like find by ID or save, these are already provided by CRUD. But this CRUD repository we don't have to define it here again, because those basic operation of save, delete and find by primary key, all those methods are already defined and part of this. So those methods will be available to us directly for use. We will see that. Let me show you my domain entity first, domain object first. So this is my domain object customer, and I have defined is as an entity, and you have to map it to a respective table in your database. So I have defined @table, and table name is customer, and my schema name is customer microservice demo. So this is my schema name and this is my customer name, so that when the JPA works, it relates this class with the table, and I have to define all those 4 attributes that we have defined in the table. Let me show you here. So ID, name, age and role, right? So same attributes we have defined here, and we have defined @ID. We are saying that this is a primary key. So in service class also, in business layer class also, I have defined 2 methods. Get customer by name, it is taking a name, and calling repository dot find by name and getting the customer list and returning that customer list. Same way I have a add customer. Add customer is a method defined in the business layer where I'm passing a customer object as is, and then it is calling customer repository dot save. Let me show you my save endpoint in customer controller. So we have this endpoint with a post mapping customer save. Now once it reaches to the service layer class, the service layer class calls a repository layer class save method to save that into a repository. Okay friends, so now let me show you the application configuration, what we have to do to connect to our database running in a Docker container. So if you see, this is my application.properties file where I have a database configuration, and in this configuration I have given localhost, that is my database is running in my local machine in a Docker container, and we'll be accessing that on port 5435. If you remember, our Docker container Postgres image is running in 5435 port, hence I have given 5435 port, and this is my default database name Postgres, and these are my username and password Postgres. I'm also using some Ikari connection pool configuration and timeout that you can define. The pool size is 5 and the timeout is 20 seconds. I'm also define my server.port to 8081 so that my microservice application should run on 8081 port, because I am running other application on 8080, hence I want to run this application on 8081, hence I have given this 8081, and I'll be accessing all the endpoints on 8081 ports. Okay friends, so now let us go and run this application and see if we are able to connect to database. So let me build this first, select the clean and install, and then just run this. So it is building the code. Try to run some test cases. Yes, so it is running the test case. Yeah, so it says build is successful. Okay friends, so now it's time for us to run the application. As we have already successfully built our application, we'll run this application and see if we are able to connect to database. Let me do that by right click on this class and then select this run microservice demo option. Yeah, so it is building. Let us see if it is able to run and connect. Very good. So it says it is able to start the Hikari pool and connection to database is successful. The dialect is started. So it is running fine. Now what we'll do is we will try to test this application by hitting those endpoints from our Postman API tool. Let us do that. So let me go to the Postman API tool. So if you see here in this Postman API tool, I'm testing a get customer contract here. I have selected a protocol type get. Our HTTP method is get, and then I have defined a given my endpoint URL here, HTTP localhost 8081 customers Pawan, because I know I have inserted one user with the name Pawan. So I'll fire this query and see if we are getting the JSON response. Once this URL is created, you have selected the get method and click on send button, right? Okay, so we got 200 response. 200 means it's successful, it's okay response, and we see the ID is 1001 and the name is Pawan and role is valued and age is 32. So this is the response what we are getting from database. Let us just quickly analyze the log as well, what happened in the log. If you see, the request reaches the controller. This is our controller class, getting the customer by name Pawan, and then this controller has forwarded request to our business layer class, that is customer service, getting customer Pawan from the repository, and then it says once it got a response from repository, it checked how many customers are there in that list, and it printed the number of record found in that list, that is found one customers by name Pawan, and then it returned that list to controller. Controller also printed that receive one customer by name Pawan, and then it finally returned to a user, that is in our Postman API tool. That's how we got the JSON response. Now what we'll do is we'll test our post contract by adding a new customer into our database. We'll test our post contract, that is we'll try to add a customer into our database. So let us do that. I'm just giving dummy ID is my ID and name is, let's say, Adam, yeah, with the role, let's say employee, and age 34. Let us do that. Let's fire this query and see what happens. Yeah, so it's saying 200, that is successful, that user is added, and this is the ID generated, UUID generated by default. It's a primary key with the name Adam, employee, and 34. Let us quickly see in our Intellij, we'll see the logs. So what happened? So the request reach here that adding user Adam to database, then it has forwarded request to a business layer class, that is customer service, and it says adding customer Adam to the database, and then after calling the repository save method, it has printed added customer Adam successfully. Let us quickly see in database have we got that user or not. So far we just have 2 user. Let's fire this select query and see if we see the third customer in the database. Yes, so we see that Adam is added in our database successfully, okay, with the required values. Okay friends, now let me summarize what we have learned in this video. Right? Okay, so we have downloaded Postgres 12 image from DockerHub repository using docker pull command. We have started that image into a Docker container. Then we created a schema and table in that database. Then we inserted few records and fired select query on the database to confirm that it is working fine in our Docker container. Then we move to our Spring Boot Microservice Application, where I have given you walkthrough of controller class, business layer class, repository interface, domain class, and then at the end we have given the database configuration in our application properties file, right? So we have done that. Then we have tested our application and we have fired the get and post command using postman API tool, and we successfully got a response for our API calls. Right. Okay friends, so if you like this video, so give it a thumbs up and do share it with all your friends and colleagues, because this is very important information for a beginner and a student. And if you are new to the channel, so please do subscribe to my channel to grow Code One Digest family. Friends, I am creating lot of quality contents on programming concepts, coding concepts, and cloud and container technologies, Spring Boot framework, Java framework, Java multi-threading concepts, design patterns, architecture principle. I'm creating a lot of videos on all these contents, but I'm not getting subscribers. I need your help in growing the Code One Digest family. So if you're new to the channel, so please do subscribe to this channel and share it with all your friends and colleagues and help me growing the Code One Digest family. Thank you.